Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. My name is Azmat Ali and I welcome you all in class of Real Analysis by Robert G. Bartle. In today's lecture, we will discuss exercise 2.2, question number 1 to question number 5. In this lecture, you have to just focus on the definition of absolute value function that we will use frequently during our lecture. If x is any real number, if x is positive, then its absolute value is positive x. If your x is negative, then absolute value of x is simply minus x. And in case if your x is 0, then its absolute value is equal to 0. This is the key of today's lecture. The absolute value of a positive real number is positive. The absolute value of a negative real number is minus x. And in case if your real number is 0, then its absolute value is equal to 0. Question number 1. If a and b are any two real number and b is a non-zero real number, we have to show that the absolute value of a and the square root of a square both are same for any real number a. As absolute value of a is equal to negative a if a is less than 0. This is equal to 0 if a is equal to 0. If this is equal to positive a if a is greater than 0. So the absolute value of a is a piecewise function that consists on these three parts: negative, equal to 0 and greater than 0. Similarly, if you notice, the square root of a square, this is equal to 0 if a is 0, because you know the square root of a 0 is 0. Square root of a square is equal to a if a is greater than 0. Similarly, square root of a square is minus a if a is less than 0. As both a absolute and a square root of a square have the same definitions, so they are equal for every real number a. Second part. In the second part, we have to show the absolute value of this fraction a over b is equal to a fraction of these absolute values, where b is non-zero and there is no limitation on a. In case if a is 0, then the left hand side becomes 0 over b absolute. This is equal to 0. This is equal to 0. While the right hand side becomes 0 absolute over b, whatever will be, but should be non-zero. This is equal to 0. So in both cases, in case when a is 0, both left hand side and right hand side are equal, so equality holds. Now we discuss these four cases when a is non-zero and it is given b is also non-zero. A non-zero mean a could be greater than 0 or less than 0. Similarly, b could be greater than 0 or less than 0. So case number 1. If both are greater than 0, mean to say both are positive. If both numbers are positive, then clearly their fraction a over b is greater than 0. For example, if my a is 5 and b is 2, then what is a over b? A over b is 5 over 2, which is clearly greater than 0. So a over b is greater than 0. As above, I said that if a number is positive, then its absolute value is equal to itself. So a over b, absolute value of a over b is simply a over b. So this is my left hand side. What will be right hand side in this case? My right hand side is a absolute over b absolute. As a is positive, so in case when a is positive, then its absolute value is simply equal to a and its absolute value of b is equal to b. So this is equal to a over b. So in both cases, both sides, a over b absolute value and absolute of a over b absolute, both are equal to a over b. Case number 2. if both A and B are negative. In case when A and B both are negative, then again in this case their fraction A over B is always greater than 0. For example, if you take A is equal to minus 5 and B is equal to minus 2, clearly A over B is equal to minus 5 over minus 2. This is equal to 5 by 2, which is greater than 0. So again, the final fraction A over B is greater than 0. So if a number is greater than 0, then its absolute value is simply equal to that number A over B. But on the other side, A absolute is equal to, because A is negative here, so its value is minus A. Similarly, B is negative here, so its absolute value is minus B. And what is the ratio A absolute over B absolute in this case? A absolute over B absolute is equal to minus A over minus B. Cancelling out minus, we have A over B, which is equal to A absolute of A over B. So absolute of A over B is equal to A over B, which is equal to A absolute over B absolute. So equality hold for case number 2 also. Similarly, we can discuss the remaining these two cases if A is negative and B is positive. If A is negative, B is positive, then the final fraction A over B will be negative. Now if a number is negative, then its absolute value is negative of the number minus A over B. On the other hand, if A is negative, so this is equal to minus A, and B is positive, so its absolute value is equal to positive B. And the right hand side, A absolute over B absolute is equal to, what is A absolute? This is equal to minus A, and B absolute is equal to B. So both are equal. And similarly, you can see the case number 4. In this case also, this equality hold. Next, we move towards question number 2. Question number 2 is a very nice question. Actually, this question is a part of triangular inequality. This question says if A and B are real number, then we have to show that the absolute of sum of two real number is equal to sum of their absolute if and only if AB is greater than equal to 0. The product is greater than equal to 0. In other words, we can say that both A and B have the same sign. Then this equality hold. For example, if you take A is equal to 5, B is equal to 2, then you can observe that A plus B, that is 5 plus 2, this is equal to 7. On the other hand, 5 absolute plus 2 absolute, this is equal to also 7. But if you take A is equal to minus 5 and B is equal to 2, in other words, here A and B have an opposite sign. Now if you find A plus B, that is minus 5 plus 2, this is equal to minus 3. Minus 3 absolute is equal to plus 3. While its right hand side is minus 5 absolute plus B absolute, that is 2 absolute. Minus 5 absolute is 5 and 2 absolute is 2. This is equal to 7. So in this case, this equality does not hold because A and B have an opposite sign. So question number 2 actually wants to say this equality hold if and only if A and B both have the same sign. In that case, their product will be greater than or equal to 0. Suppose that, firstly I suppose the product is greater than equal to 0, and I will show this equality hold. As here product is greater than equal to 0, so it means either AB is equal to 0 or either AB greater than 0. So firstly we discuss this case. If AB is equal to 0, product is equal to 0, suppose if A and B both are equal to 0 here, then clearly their sum A plus B is equal to 0, which is equal to A absolute plus B absolute here. So the equality hold. Second case. Now AB should be greater than 0. That is product should be greater than 0. Now product is greater than 0 means they both have same sign. Either they are positive or they are negative. So firstly we discuss the case of positive. If A is greater than 0, B is greater than 0, then finally their product is greater than 0. As a is greater than 0, so in this case their absolute value is equal to a, and absolute value of b is equal to b. As a and b both are positive, so its sum a plus b is also positive. So if a plus b is positive, then clearly its absolute is equal to a plus b. So a plus b absolute is equal to a plus b, as a is equal to a absolute and b is equal to b absolute, so equality hold. Case number 3. If a and b both are negative, but their product will be greater than 0. In this case, when a is negative, then its absolute value is equal to minus a, and absolute value of b is equal to minus b. As a and b both are negative, so their sum will be less than 0. As a plus b is less than 0, so its absolute value is equal to negative of the number. Because my number a plus b is negative, so its absolute value is equal to negative of the number inside the absolute. So multiply with minus sign, we have minus a minus b. What is minus a? Minus a is equal to a absolute, and minus b is equal to plus b absolute. So again the equality hold. Conversely, we suppose that these two sides are equal, and we show that the product is greater than or equal to 0 here. As this equation hold, so taking square on both sides, we have square of a plus b absolute and square of a absolute plus b absolute. We know an important result from our previous discussion. Square of an absolute is equal to square of the number. For example, square of 4 is simply equal to absolute value of 4, square of absolute value of 4, either it is 4 or minus 4. In every case, they are all equal. So square of absolute is equal to square of the number a plus b. So we can ignore the absolute value simply here, absolute sign here. By expanding a plus b whole square, this becomes square of first, square of second plus 2 times first into second. Again, using the formula of a plus b whole square on the left side, by ignoring the absolute sign here, this becomes a square plus b square, and by combining both terms into a single absolute, this becomes 2 into ab absolute. Cancelling out a square from both sides and b square also, and dividing 2 on both sides, we have remaining a absolute of ab is equal to ab. Now you have to see for what values of a and b the equation 1 hold. Case number 1. If ab is equal to 0, this product is equal to 0, then clearly 1 hold. When you put here ab is equal to 0, this becomes 0 absolute, which is equal to 0. Both are equal. Case number 2. 1 also hold if a and b both have the same sign. So either if ab is greater than 0 or ab is less than 0, in both cases. In both cases, your product AB is greater than 0. And if AB is greater than 0, then clearly its absolute value is simply equal to AB, which is greater than or equal to 0. So finally, 1 hold for greater than or equal to AB greater than or equal to 0. Hence, this equation hold if and only if AB is greater than or equal to 0. And it completes the question number 2. Question number 3. Question number 3 says if x, y, z are 3 real number and x is less than or equal to z, show that if we insert a number y between x and z such that x is less than or equal to y, y is less than or equal to z, if and only if this hold, if and only if the sum of these two distances is equal to sum of this distance, x minus y absolute plus y minus z absolute is equal to x minus z. And it also says interpret the result geometrically. Okay. It is given that x is less than or equal to 0. Firstly, we show that this result hold, this relation hold, then this equality hold. This is nothing, I have right mistakenly here. First case, as it is given that x is less than or equal to y, y is less than or equal to z. So if we take they are equal, if x, y, z, all these three are equal, then clearly x minus y, y minus z, x minus z, their absolute value is simply equal to 0. So 0 plus 0 equal to 0. So equation holds. Next, consider when x is less than y, y is less than z. When x is less than y, from here we simply write x minus y. This is, you can cancel here this part. When x is less than y, this is simply x minus y is less than 0. If a number is negative, then its absolute value is simply negative of the number, that is minus of x minus y. This is equal to minus x plus y. Similarly here, y is less than z means y minus z is less than 0. It means y minus z is negative. Y minus z is negative mean its absolute value is simply minus time y minus z, or we can write minus y plus z. Similarly, when x is less than z, it means x minus z is less than 0. It means its absolute value is minus time x minus z, which is minus x plus y. Now consider left hand side. What is the left hand side? Absolute of x minus y plus absolute of y minus z. What is absolute of x minus y? This is equal to minus x plus y. This is equal to minus y plus z. Cancelling out y, we have minus x plus z, which is equal to absolute of x minus z. Conversely, we suppose that this equation hold, and we will show this relation. To prove this relation, I will use contrapositive. This is contrapositive statement, not a contradiction. This should be contrapositive. What does mean by the contrapositive? If you have some basic of discrete mathematics, then if we have a conditional P implies Q, then its contrapositive is negation Q implies negation P. Both these conditionals have the same truth tables, same truth values. So if P implies Q is true, then this is true. If this is false, then this is false. So I will show that if this is false, then star will not hold. So I will take, as actually here it is given x is less than or equal to y, but I will take its false part. I will take if y is less than x and or y is greater than z. By taking y less than x and or y greater than z, we will show that this star will not hold. This is our target. If y is less than x, then what does mean? This means y minus x is less than 0, or in other words, we say that x minus y is greater than 0. X minus y is positive, it means its absolute value is simply x minus y. Y is greater than z mean y minus z is positive. Y minus z positive mean its absolute value is simply y minus z. X is less than or equal to z mean x minus z is less than or equal to 0. This is equal to x minus z is, because this is non-negative, so its absolute value is minus time x minus z, that is minus x plus z. And in case when x and z are equal, in other words, when x minus z is equal to 0, then clearly both sides are equal to 0. Okay, now I am solving the left hand side. What is left hand side? This is my left hand side. You will see I will solve left hand side under these conditions. It should not be equal to x minus z absolute. X minus y absolute plus y minus z absolute. What is x minus y absolute? This is x minus y. What is y minus z absolute? This is equal to y minus z. By cancelling y, we have remaining x minus z. This can be written, this is not equal to x minus z is not equal to minus time x plus z, and minus x plus z is equal to simply x minus z absolute. This shows that this side is not equal to absolute value of x minus z. Hence, we can say that this equation, if this equation hold, then this relation hold, and if this relation hold, then these are equal. Otherwise, both results are not true. Geometrically, x minus y absolute, y minus z absolute, x minus z absolute, these all represent the distances between points x, y, and z. This is distance between x, y, this is distance between y, z, and this is the distance between x and z. This equation holds if x, y, z are collinear. Collinear means they lies on the same line, and y, and this hold if y lies between these two number x and z. You can observe, see from this figure. These are the 3 points x, y, z. If x, y, z lies on the straight line, same straight line, and y is inside x and z, then clearly the distance between first two, that is x minus y, and the distance between y and z, this is y minus z, and their sum is x minus y plus y minus z, and this sum is simply equal to the distance between first and the last, that is x minus z absolute. So this equality hold when x, y, z are collinear, y lies inside x and z. In case if y does not lies between x and z, in that case points will be non-collinear, and in that case these 3 points will form a triangle, and in case of triangle we will follow a triangle inequality. So in case when y does not lies between x and z, these points are non-collinear, and in that case geometrically these distances form a triangle, and in this case x minus z absolute less than x minus y absolute plus y minus absolute z absolute, that is triangle inequality. Next we move question number 4. This is very easy question. Show that the absolute value of x minus a is less than epsilon if and only if x lies between these two numbers, a minus a epsilon, a plus epsilon. We consider x minus a is less than epsilon. I will use just this definition. If absolute value of x is less than a, then it can be written as minus a less than x, x less than plus a. That is, x can be bounded by these two numbers, minus a plus a. So this is my number x minus a. This can be bounded by minus a, minus epsilon, and plus epsilon. By adding a on both sides, we have a minus epsilon less than x, x less than a plus epsilon. By taking the reverse sign at the same time, we can prove the result. Question number 5. This is also an interesting question. This question says that if x is any real number that lies between a and b, and y is another number which also lies between a and b, we have to show that the absolute difference of x and y is always less than b minus a. Interpret this result geometrically. I will prove this question very easily. It is given that a is less than x, x less than b. Say this is my inequality number 1. The second is a less than y, y less than b. If we multiply this inequality by negative sign, we have minus b minus y less than minus a. Now adding 1 and 2 with their respective sides, so this becomes a plus minus b, this is a minus b. Adding x with minus y, this becomes x minus y. Adding b with minus a, this becomes b minus a. Can we write it as a minus b is equal to minus times b minus a by taking minus common from here? This becomes minus times b minus a, this is less than x minus y, this is less than b minus a. Again, using the concept that I have discussed above, x absolute less than a if and only if minus a less than x, x less than plus a. So x minus y, this is my central number, which is less than b minus a and greater than negative of b minus a. So it can be enclosed by x minus y absolute less than b minus a. That is required to prove geometrically. Geometrically, it shows that if x and y lies between the two, between an open interval ab, then the distance between x and y, distance between x and y, that is x minus y absolute. This distance is always less than the total length of b minus a. Look here, This is my first number A and this is my second number B, and X and Y are any two real numbers between A and B. Possibly that Y is greater than X or Y is less than X. So that's why we are, for the safe side, we are taking absolute value of their difference X minus Y. So the absolute value of X minus Y is always less than the total length of B minus A. For example, if you take A is equal to 3, my X is equal to 5, my Y is 10, and my B is suppose 13. Now the absolute difference of second and third number, that is X minus Y, 5 minus 10. This will always less than or equal to the total length of this interval, that is 13 minus 3. 5 minus 10, this is minus 5. Minus 5 absolute is 5. And 13 minus 3, this is 10. So you can notice that the difference between any two numbers that lies in this interval is always less than the difference of total length. So I hope now you have a clear understanding of today's lecture. Inshallah, in the next lecture we will start from question number 6. If you find this lecture helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.